I'm back. Have you ever wondered why do we have this, and this? Well, just keep your eyes open and let's see the beauty of everything with colors of visible light.
For this lesson, we have 3 learning objectives. First, explain that light is composed of colors of different frequencies and wavelengths. Second, interpret the arrangement of colors of light that shows the hierarchy of the colors corresponding energy. Third, convert units of frequency and wavelength. So, for us to know how far you learned from this lesson, I want you to try answering these questions. Directions: select the best answer and write the letter of your choice in your notebook. Number 1. Which of the following shows the correct order of the different colors of light? A. Biv G. Roy. B. Biv R. Goy. C. Roy B. Give. D. Roy G. Biv. Number 2. Which color has the highest frequency but shortest wavelength? A. Blue. B. Green. C. Violet. D. Yellow. Number 3. How is wavelength related to energy of the colors of light? A. Wavelength does not depend on energy. B. Wavelength is directly proportional to energy. C. As the wavelength increases, the energy of light wave increases. D. As the wavelength becomes shorter, the energy of light wave increases. Number 4. Which color has the lowest frequency but longest wavelength? A. Orange. B. Red. C. Violet. D. Yellow. Number 5. How is frequency related to the energy of the colors of light? A. Frequency does not depend on energy. B. Frequency is inversely proportional to energy. C. As the frequency of light increases, the energy decreases. D. As the frequency of light increases, the energy also increases. So let us have the unlocking of difficult terms used in this lesson. Wavelength is the horizontal displacement from crest to crest and trough to trough of a wave. Visible light is the only part of the electromagnetic spectrum that can be seen by the human eye.
Alright, it's explore time. Get ready for more activities that you are going to perform and answer. Our third activity is entitled Color Spectrum Wheel. And so now, let's turn the wheel of the color spectrum. In this activity, we need the following materials:
color spectrum wheel pattern cardboard or illustration board, white screen, it's optional, glue or paste, button fastener, and scissors. For the procedure, first, draw and cut the two art files that make up the wheel on the next slides. Caution: be careful in using the scissor with a sharp blade and pointed edges. So, you may download these two art files on the link below. Third, punch a hole at the center of the two wheels. You may use a button fastener to secure the two wheels together, one on top of the other, but they should be free to rotate relative to each other. And lastly, when you see a region of the color spectrum show up in the open window, the wavelength, frequency, and energy that correspond to that region will also show up under the flaps.
Have you done it right? Well, I will show you the model of the color spectrum wheel, and it should look like this. So, let's try out by positioning the innermost of the flaps on color spectrum. This will simultaneously position the other flaps to frequency, wavelength, and energy. Now, let's turn the back wheel clockwise and keep an eye as you observe the combinations. So for red, orange, yellow, green, blue, and violet. Did you follow? I'm sure that you are ready for your first task. Enjoy!
For our first task, it is entitled Characteristics of Light. Direction: fill in the table on the next slide with the corresponding combinations you have observed using your spectrum color wheel. Draw this table in your activity notebook. In this, you will write the frequency, wavelength, and energy of the different colors of light. You can pause this video for a few minutes. Your answer to this will be collected and will be checked by your science teachers. Our first task does not end there. Here's the continuation of it. Task number 2, again, is entitled Characteristics of Light. Directions: you will need to convert the equivalence of frequencies to hertz and the equivalent wavelengths to meters. Fill in the table on the next slide after the sample conversion. Before we proceed, please take note of the following equivalents. Tera, T, is a prefix for 10 raised to the power of 12. 1 terahertz is equal to 1 times 10 raised to the power of 12 hertz. Nano, N, is a prefix equivalent to 10 raised to the power of negative 9. 1 nanometer is equal to 1 times 10 raised to the power of negative 9 meters. So, in order for you to have an idea of how to convert units of frequency and wavelength, study first the sample conversion. Please pause this video for a few minutes. Now, draw this table in your notebook, and you may start immediately. Get your activity notebook and pen and answer the following guide questions. Be reminded that your answers will be collected and will be checked by your science teachers. Number 1. Which color registered the highest frequency? The shortest wavelength. Number 2. Which color registered the lowest frequency? The longest wavelength. Number 3. What did you observe about the wavelengths and frequencies of the different colors of light? Number 4. Does the frequencies of the colors of light increase from red to violet? Number 5. What did you observe about the corresponding energies from red to violet? Number 6. How is frequency related to energy of colors of light? And number 7. How is wavelength related to the energy of the colors of light? Okay, class, keep these informations in mind. Each wavelength is perceived by our eyes as a different color. The shorter wavelengths of visible light are violet. As the wavelengths get longer and longer, the visible light changes in color to blue, green, yellow, orange, and finally, the longest, which is red. The higher the frequency, the faster the oscillations, and thus the higher the energy. Therefore, the highest frequency with the highest energy is violet. Alright, get your pen and notebook. It's time to apply the learnings you gained in this lesson. So it's entitled, Colors and Energy, How Will I Explain You? Directions. Use the data in the table to complete the statements on the next slide. As I always said, your answers to these will be collected and will be checked by your science teachers. A. Light is composed of colors of different blank and blank. B. Colors of light show frequencies in blank order. C. Colors of light show wavelengths in blank order. D. Colors of light show energies in blank order. E. As the frequency of the colors of light blank, the wavelength blank. F. The frequency and energy of the colors of light are blank. G. As the frequency of the colors of light blank, the energy blank. And H. As the wavelength blank, the energy of the colors of light blank. Congrats, class! You did it well!